Today we will learn about some tools of the trade. One very important tool is Excel, which allows you to simply and quickly generate graphs and perform complicated calculations in a methodical and WYSIWYG way. That is, what you see is what you get. This movie will take you through a simple procedure on a Mac. It is important to remember that Excel and all other programs are tools that allow you to program a process that you have already defined clearly for yourself. For example, if the problem is to graph a cosine function, you need to fully understand all the properties of the cosine function. Here I have written the cosine function with all the parameters that characterize its behavior. A is the magnitude, f is the frequency, and phi naught is the initial phase. But first, let's talk about the distinction between f and omega. If I imagine the radius of a circle rotating at a constant angular frequency, then I need a way to define that angular frequency. I can use omega, which denotes how fast it is rotating in terms of how many rads it covers in 1 second, or I can use f, or frequency, to denote how many full circles it completes in 1 second. On the figure on the right, I have drawn radii at 1 rad, 2 rad, 3 rad, 4 rad, 5 rad, and 6 rad. A full circle is 2 times pi rad, that is a little over 6 rad. So again, omega would tell us how many of these radians my radius would cover in 1 second as it's rotating around the circle, whereas f is how many full circles the radius completes in 1 second. So f is smaller than omega, and because a full circle is 2 times pi radians, omega is equal to 2 times pi f. But what does a circle have to do with a cosine? Well, if I play the movie for you, you'll see what happens as the radius rotates around the circle, and as it rotates, I plot the projection of its tip on the y-axis, and that's the figure that you see on the right-hand side, and also its projection on the x-axis, and that's the figure that you see on the bottom. So again, if I take this projection, but I move it along the time axis to correspond to the time at which the radius is at that point, then I get the sine function, which is a projection of this radius on the y-axis, and the cosine function, which is a projection on the x-axis. So in fact, when I'm talking about sine and cosine, I'm really describing this rotation of a unit vector or a unit radius on a circle. So how do I graph the cosine function? I start Excel and choose blank workbook. In the box corresponding to column A, row 1, I fill in the number 0. Then I go to the far right and pull down the menu Fill and choose Series. Make sure in the box that gets generated that you choose columns and fill in a stop value. Otherwise, the automatic selection is rows, and you're going to end up filling in data in a row. Hit OK, and you should get a list of numbers from 1 to 6 with a step size of 1. In other words, 0, 1, 2, 3, 4, 5, 6. Now you go to E1 or somewhere else on your page and enter mag, and underneath that you enter the number 10. Go to Insert, and that's in the ribbon on top of the page. Go to Insert and then hit Name and Create. This actually creates a parameter called mag that you can use in your equations. Once you hit Name Create, you will get the box on the right-hand side, and you're going to just create a name in the top row. In other words, this is telling you that mag, which is in the top row, is the name, and whatever is underneath mag is the definition of mag. So mag in your instance is 10. Now, in order to graph the cosine, then you want to repeat the same process again for FREQ, which is the frequency. And so you go Insert, Name, Create, and that's going to be your frequency 1. Now go to B1 type in the equation for the cosine function, and with mag as the magnitude and FREQ as the frequency. So that's mag times cosine 2 times pi times frequency times A1. Note that pi for Excel is the pi with the open and shut parentheses. Note as well that when you type in mag and FREQ, the corresponding values are highlighted over under E and the column E and the column F. So now you've got, if you hit enter, the value that you see under B is 10, which is that 10 times cosine of 0. So you select the box B, you hover over its bottom right hand corner, and what you're going to see, which you can't see here because it won't get captured in a screen capture, is that from a thick plus sign, your cursor shape will turn into a thin plus sign, and at that point you can select that corner and drag down. And when you drag down, you will actually fill the rest of the boxes with the calculated values for that same function that you typed above, except for each subsequent box it's grabbing the corresponding values from column A. So that A1 in the second box would be A2, and the third box would be A3, and so forth and so on. But you do see that something unexpected is happening. Your values are not changing. But let's look at our function. Again, remember you have to understand what it is you're plotting. Cosine 2 pi times 1, which would be your box B1, is actually equal to cosine 2 pi times 2, and so forth and so on. In other words, cosine of 2 pi times an integer number is actually equal to 1. So because you did not choose the correct discretization of your time series, you end up, totally by chance, with a column in B that's equal to 10. So it really matters how you discretize your. Again, if you look at these values, you will see you've got 10 minus 10, 10 minus 10. Again, I think that's a good hint that you're not going to get something that looks like a cosine, but let's go ahead and graph it. I go under Insert, and you have a lot of options. You want to choose the type of graph that you want to graph. I'm doing points with straight connecting lines, and I get this. And obviously this also does not look like a cosine, and probably it still doesn't look like a cosine because I need to refine my step size even further. So really what this is doing is my cosine is going between 1 and minus 1, and then with a magnitude of 10, so it's going between 10 and minus 10. So I refine my step even further, choose a step size of 0.1, and I notice that my graph does update every time I change these values, but because I had already chosen values from 1 to 13, that doesn't change. But I can actually grab the bottom right corner of B13, and you notice that when I've got the graph chosen, the data is actually highlighted, so that purple and blue, that's what happens on Excel when you grab the chart. So you can just grab that and drag it down, and so now you have a better looking graph. You still have to do some work. You have to name the y-axis and add the units, name the x-axis and add the units, and if you want, you can add a title. You can do that either by going over to the left-hand side. If you look at the top, now I'm under the tab called Chart Design, and I can just define what I want to put on my graph. I can put axes, axis titles, a chart title, data labels, error bars. All of these are things that you should investigate on your own time. But there are some just ready-made graphing options for you. I just chose one, and then I did enter. You do have to enter the axis titles with units, and this is the graph that I got. And so now you've got a cosine. It's still not perfect, obviously. I should have refined the step size even further, but at least you get an idea of how you would go about graphing it and how you would go about selecting things like step size, what the what the minimum value is that you want to graph, and maximum value. There are a lot of decisions that you have to make before you even start graphing your function.